Okay, let's go about this problem. If quadratic equations x squared plus bx plus c equals to 0 and x squared plus bx plus q equals to 0 have a common root, show that c minus q, the whole of it squared, equals to into b minus p into cp minus bq. We are given x squared plus bx plus c equals to 0 and x squared plus px plus q equals to 0, and we are required to show that c minus q, the whole of it squared, equals to into b minus p into cp minus bq. Let's call this equation 1 and this equation 2. To solve this, we should understand that for two quadratic equations to have a common root, there should exist at least one value of x that satisfies both equations simultaneously. Let's eliminate x squared. So, equation 1 minus equation 2. This implies that we have x squared plus bx plus c equals to 0 minus into x squared plus px plus q equals to 0. So, x squared minus x squared, we get 0, plus bx minus px, we remain with plus bx minus px, then plus c minus q. C minus q equals to 0 minus 0, we remain with 0. So this is the same as x is common, we have x into b minus p plus c minus q equals to 0. So let's make x the subject of the formula. This will become x equals to negative c minus q all over b minus p. So let's substitute this value of x in any of the equations, equation 1 or equation 2. So from equation 1, x squared plus bx plus c equals to 0. On substitution, this will become negative into c minus q all over b minus p, the whole of this squared, plus b into negative into c minus q divided by b minus p plus c equals to 0. So this is the same as c minus q squared divided by b minus p squared minus b into c minus q divided by b minus p plus c equals to 0. Let's multiply through by b minus p squared to eliminate the denominators. So this is the same as b minus p but squared into c minus q squared divided by b minus p squared minus b into c minus q divided by b minus p plus c, close the bracket, equals to 0 times b minus p but squared. So this is the same as b minus p squared times this will remain with c minus q but squared minus, here we remain with b into c minus q into b minus p, then plus c into b minus p but squared equals to 0 times anything equals to 0. But from the problem we are required to show that into the bracket c minus q, the whole of it squared, equals to b minus p into cp minus bq. So let's make this the subject of the formula. It will become c minus q squared equals to b into c minus q into b minus p, but minus this term, when it crosses the equal signs, it becomes a negative. So we have minus c into b minus p, but squared. So this is the same as c minus q squared equals to b minus p is common. So we factor it out. It will become b minus p into, in this term, we remain with b into c minus q minus, in this term, we remain with c into b minus p. This implies that we have c minus q squared equals to b minus p into b times c, this is bc, and b times q minus bq minus c times b, the same as c, b, then negative c times negative b, same as plus cp. bc and negative cb, they cancel out, so we remain with c minus q squared equals to b minus p into negative bq plus cp. But we are required to show that c minus q, the whole of it squared equals to b minus p into cp minus bq. So let's just rearrange this bracket. Therefore, this is the same as c minus q squared equals to b minus p into cp minus bq as required.